I'm going to show you how to use combustion analysis to solve a fairly complex problem, which is figuring out the molecular formula of X. What is X? It is some compound that is made of carbon, hydrogen, and as it says here, perhaps oxygen. So we can represent that formula as you see up here, and we're just going to call it CXHYOZ. And we're trying to figure out the formula of this compound. What we know from the problem is we burn it in oxygen, and when we do, it produces carbon dioxide and water. So we have some additional information in this problem. One thing is that the mass of this unknown compound is 8.0 grams. And we're also told the masses of carbon dioxide and water, 27.51 grams for carbon dioxide and 4.50 grams for water. So the key to solving this problem is recognizing that the carbon that comes out in CO2 must have originated from the carbon that was burned. At the same time, the hydrogen that shows up in the water product must be equal to the hydrogen that was burned. So we're going to use that concept in order to enable us to calculate the moles of carbon and hydrogen, which in turn will illuminate the empirical formula of this compound. So let's go to step 1 here. And notice that we take the grams of CO2, which is 27.51 grams. We divide it by the molar mass of carbon dioxide, and then we use the mole-to-mole ratio. There is 1 mole of carbon for every 1 mole of CO2, and that gives us that we have 0.625 moles of carbon in this 27.51 grams of CO2. Again, this must be the same molar quantity as what is in our unknown compound. So basically, we have the start of an empirical formula here. We can say that Cx, our x, must be 0.625. Okay, next up is our step 2. We have 4.5 grams of H2O. We divide that by the molar mass, and that gives us moles of water. Then we recognize that there are 2 moles of hydrogen for every 1 mole of H2O. This is a crucial step. And this is going to tell us that there are 0.499 moles of hydrogen in this amount of water. Now, again, this hydrogen in this water must have come from the compound that we burned. So now we have the second part of our empirical formula, which is going to be H 0.499. Okay, so the only thing left to solve now is what is the oxygen that is in our unknown compound, if any, because it says up here, it says perhaps oxygen. I let that be represented by Z, but now we're going to figure out, do we in fact have any oxygen? In order to achieve that, I actually need to know the gram amounts of carbon and hydrogen. So that is found in this part of the problem here. I took the moles of carbon and I multiplied by its molar mass to get 7.5 grams of carbon here. And I did it again for hydrogen down here. So we can safely say that we have 7.5 grams of carbon and 0.5 grams of hydrogen in our unknown compound. Whatever is remaining in our unknown compound must be oxygen. Okay, so what do? We know how much compound we actually started with, right? We know that we have 8.0 grams of compound. And now we've also figured out that we have 7.5 grams of carbon and 0.5 grams of hydrogen. So we're going to take our 8.0 grams of carbon, of our 8.0 grams of compound, and we're going to subtract our grams of carbon and our grams of hydrogen. A little bit of a mistake there. Grams of carbon and grams of hydrogen. Guess what? We don't have any oxygen in this compound, because when we take our 8 grams of compound and we subtract 7.5 and 5, we're left with 0 grams. So now we basically have our empirical formula. What is our empirical formula? It's C 0.625 and H 0.499. We do what we usually do with empirical formula. We divide by the smallest quantity, and this gives us C 1.2501. Then, of course, we have to multiply by 4 to get a whole number, and this gives us an empirical formula of C5O4. Now, we're also given a molar mass in this problem of 128 grams per mole. So when we calculate the mass of the empirical formula, we get 124.05 grams. This is actually pretty close to 128 grams per mole, so this means our empirical formula is the same as our molecular formula. The answer is C5O4. Now, just to review a few of the concepts here, we took grams of CO2, we converted to moles of CO2, and that gave us moles of carbon. That was step 1. The moles of carbon in CO2 are going to be equal to the moles of carbon in our unknown compound. Good. In step 2, we said, okay, we have 4.5 grams of water. We can get moles of water. From the moles of water, we can get moles of hydrogen. Those moles of hydrogen are going to be the same as what was in our original compound. Oxygen is a little trickier. We burned our compound in oxygen. So we don't know whether the oxygen in the carbon dioxide and the water is coming from the oxygen that we used to burn our compound, or whether it's coming from the oxygen that is in our compound, if any. That leads us to step 3. The way to get at grams of oxygen is to take grams of carbon and grams of hydrogen that we know are in our unknown compound and subtract them from the starting amount of compound. Once we have that, we can calculate our empirical formula as just shown.